Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the summative questions. It's question number 10. And it's basically just a diagram and it says determine the unknown values of x, y, and z. So x is here and it's part of this non-right angled triangle. Z and Y are two sides of this right angle triangle, but I don't really have any measurements except for this 2.24 length. So I can't really do anything with Y and Z right now. So let's focus on X. X is part of a triangle, so the ABD triangle, and let me recopy the ABD triangle as best I can. Heck, I'll use my fancy tool. So ABD looks something like this, close enough. We'll live with it, right? And I know a few things. So for example, I know that angle A is 33.69 degrees, and I know that the opposite side, which would be side A, is 2.24. And that's good because I know an angle and its opposite side, I get to use the sine law. I also know that this side over here, which would be side little d, um, I know the length of that, that's 3.61, and the angle I'm looking for, which is x, is opposite it, which means I can use the sine law to solve for x without doing any other math in between. So let's set that up. I know that sine A over side A is sine D over side D. So A over A is D over D. Oops. And so what are the values that I'm going to substitute in? So angle A is 33.69. Side A is 2.24. I don't know angle D, but side D is 3.61. And so now I can just do this math. So we solve by cross multiplication. So 3.61 times sine of 33.69 is equal to 2.24 times sine D. So to isolate sine D, I need to divide by 2.24. So if I divide by 2.24, this is what I get. Divided by 2.24, and that calculation will give me the value of sine D. So let's go ahead and calculate that. So sine 33.69 times 3.61 divided by 2.24 gives me 0.8940, rounded correctly to 4 decimal places. And now to actually find angle D, I just need to do inverse sine. And I have the value of angle D, which is also x in the diagram. So inverse sine on that, I get 63.4 degrees. So angle D is 63.4 degrees, which means x is 63.4 degrees. So I'll just emphasize that. Yay, I know the value of x. Okay, so let's go back to the diagram because now I know the value of x. It's 63.4 degrees. So now I need to find y and z, and they're part of this right angled triangle. And this is where I'm a little suspicious that there's a piece of information missing from the question. Because I think that this is intended to be a right angle. Now, we're not supposed to assume stuff like that, but I'm pretty sure it needs to be a right angle to get this done. The other information that you maybe could have been on here is that this line is parallel to this line, because then you would also know that it's a right angle. So I'll clarify that, and so if this video still exists, I'm right. Yay! Hopefully I'm not missing something important because I'm supposed to know how to do math pretty reasonably well. But I'm pretty sure that we're supposed to have a right angle there, because if I have a right angle there, that's a 90-degree angle. And I know that this part of that angle, which is x, is 63.4, so I can find this part of the angle through subtraction. So let's go ahead and do that. I'm going to call this angle something, because right now I don't know what it is. I'm going to call it W, just because I don't want to repeat, x, y, and z, and so why not W? So what I know is that 90 degrees is angle x plus W. So W is, Oh, you'd think I could do that in my head, but, too much math. 26.6 degrees. So this angle here in the right angle triangle is 26.6 degrees. And now that I know one of the angles and one of the side lengths in that right angle triangle, I can find anything. So let's just redraw that triangle because, my page is getting a little messy over there. So we have a right angle triangle like this, do, 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 like that. Perfect. Thank you. I use a tool for that. That's not drawn by hand. We know that this side length was 2.24. We had a right angle over here, and we just calculated that this angle was 26.6 degrees, and our goal was to find the length of y and z. So now that we have a right angle triangle, we can actually use the basic trig ratios. So to set this up as a proper trig triangle, here's the angle I know, so that's theta. This side here, opposite the right angle, is the hypotenuse, and this side is adjacent to theta, and z is opposite theta. So if I want to find y, I need to find a trig ratio that relates the side I know, which is hypotenuse, to the side I want, which is adjacent. So if I scan SOHCAHTOA, there it is. Adjacent and hypotenuse are in a relationship called cosine. So cos theta is adjacent over hypotenuse. So let's sub in what we know. Cosine of the angle is adjacent, which is y, over hypotenuse, which is 2.24. So if I want to isolate y, I just need to get rid of this divide by 2.24. And to get rid of something that's divided, you multiply it. So we need to multiply by 2.24, and that'll tell us the value of y. So cosine 26.6 times 2.24 gives me 2.00. So almost exactly, and let's just say exactly, 2 units. Is it units or centimeters? Units, because there were no measurements. So that's the value of y. So to find the value of z, I'm going to do the same idea, which is now I want to find the opposite side. And again, the side that I was told was hypotenuse. So if I scan SOHCAHTOA, opposite and hypotenuse are in the relationship called sine. So sine theta is opposite over hypotenuse. So sine of 26.6 is z over 2.24. So multiply both sides by 2.24, and I will know the value of z. So sine 26.6 times 2.24, I get almost exactly 1. So we'll say 1 unit. So I'm done the question. I found x, y, and z, but I'm just going to do one quick thing, which is because this is a right angle triangle, and I know, supposedly, if I've done my math right, that this is 2 and this is 1, I'm going to check my math really quickly using the Pythagorean Theorem, which is does a squared plus b squared equals c squared according to the numbers that I've calculated. Obviously, you don't have to do this, but it's always nice to, if you have the time, to check that you're right. So I'm going to see, does c squared equal a squared plus b squared? So I'm going to set up a left side, right side table. Left side and right side. So on the left side, I have c squared. So that would be 2.24 squared. On the right side, I have a squared plus b squared. So let's see what we get. So 2.24 squared is 5.0176. This is 4 plus 1 is 5. And because of rounding, I'm pretty confident that this works. So I think my answer is right, that I've solved for x, y, and z properly. Okay, thanks for watching. See you later.